Hey everyone, welcome back to my daily coding series. Today's day 75. Um, let's try today rotate array. So I haven't looked at this before. It's taking a long time to load. Okay. So given an array integer nums, rotate the array by k steps, where k is non-negative. And we must modify it in place. So for instance, if we have 1, 2, 3, 4, 5, 6, 7, and k equals 3, we want to rotate everything by 3 positions. So we would do 5, 6, 7, 1, 2, 3, 4. Let me just make sure. Okay, I'm not muted. So what does this... Okay, so that's the answer. And then let's just look at another one. So if we have -1, -100, 3, and 99, and k equals 2, everything's going to go up 2 spaces. So we'll say -1 goes up 2 spaces. So 3 would be first, right? And then 99, and -1, and then 100. Okay. So my question is, can we rotate longer than the number of arrays? Yeah. So we could rotate it several different ways. So it may be worth it to, this might be an optimization, but like we know that rotating 3 times, so if we have an array of, let's say, size 5, rotating it 5 times is the same as rotating it 0 times. Because it would be 1, 2, 3, 4, 5. So it's kind of like if you think, like 360 degrees, like we end back where we are. So rotating it 5 times is the same, rotating it 10 times is the same. So any multiple of 5, so let's say n is length, then any multiple of n is same as 0. And then similarly, if we go back to n equals 5, k equals 1 is the same as k equals 6 is the same as k equals 11. So this reminds me of like mod arithmetic. So what we can do is say that k equals k mod length of nums. So we would basically just reduce it to the remainder. So that way we'll always be working with a number that's between 0 and the length of the array minus 1. Okay, so I'm going to assume, using that logic, that k will always be greater than or equal to 0 and less than the length of nums. So this is my assumption because we will use this here. Okay. So how I'm thinking of actually doing this is, so let's say k equals 2. We want to shift everything. So 4 would start. Okay, so the way I'm doing it as a human is I'm looking like, okay, what's the starting point? And then I'm just filling in everything after that. So I'm saying, okay, well, we can identify 4 as the starting point. So then I'm just putting in 5 and 1, 2, and 3, but I'm not really doing it in place. I'm not really doing it in place because if we were doing it in place, we would lose this information. So that's not a valid way to do it. So if we have 4, 5, 1, 2, 3. So we could have like 2 pointers and think of it maybe in terms of swaps, or because we know that, like for instance, 4 goes up 2 characters, 1 goes up 2 characters, 3 goes up 2 characters. So could we just like keep doing something like that? So we'd have 4, 2, 3, 4, 5, and then we have this 4. So where would this 4 be? Well, this would be assigned to 2 spaces behind it. And then this 2 would be assigned 2 spaces behind it, so 5. And then this would be assigned 2 spaces behind it, 3. And then this would be assigned 2 spaces behind it, 4. So that wouldn't work because we need to store this information. So I could think of a brute force way of doing it. First, maybe may be a better problem solving technique. So as you can see in these examples here, it says that we'll rotate 1 step to the right, 2 steps to the right, and 3 steps to the right. So one rotation is O of n, and then you would do n times k rotations, or you do k rotations, and you would just kind of do it that way, and you don't do any shortcuts. Like you don't jump towards the last one. You actually physically do the rotations. So you would have a function called rotate array, and then you would call for something in range k. So we could just say for I in range k. Then we could say call rotate array. And this would, so we want to have the same, so yeah, maybe instead of a function, we could just, do the rotation right here. And then we would have, nums, and then it would just modify nums every single time. So that would be O of n times k. So I get started maybe with that. And the same rule applies here, so we can still do this. So combining these techniques, I'll implement the solution. So we'll say k equals k mod the length of nums. So basically just the remainder from the multiple. Okay. So if we want to rotate one array, so let's say rotate array once, then basically I'm thinking we can just do a series of swaps. So if we 1, 2, 3, 4, 5, 6, 7, we would probably start from, I guess it doesn't, maybe start from the second position. So you would say so this would become the previous, maybe you don't even swap anything. You just say, okay, this becomes the previous element. So we'd store so we'd store 2. So we'd call that like current equals 2. Then we would say 1 becomes the previous element, which is 7. And now, okay, so we'd have to store the previous one. So, and we'll initialize previous to the last index. So previous will be 7. So we're going to set this index to the previous, or this element to the previous index, previous element. So we'll say this is 7 because we initialized it. And then after that, so we update previous. Now this is previous is 1, so we make this equal to 1, and then we update to what it was, 2. And then this is 2, and then we update previous to 3, and so on. And then that would give us this. And then we would just do it that many times. So let's try implementing that. So we'd say previous equals nums of -1. And then we'd say for elements, so for num and nums, I guess we could say, so this will just repeat the code. So for I in range length of nums, we will say that nums of I equals previous, and we'll just say, so this would be like, this one becomes, yeah, so we need a temp. So we'd say temp equals nums of I becomes previous, and then previous becomes temp. So if I just try this one rotation before I worry about this, and then I print out what nums is. So this should rotate it one time. So we could see, yeah, my output rotates it exactly one time. So then I just have to repeat this code k times. So for underscore in range k, because we're not really using the underscore variable. Okay, so this, I'm guessing is probably too slow. So let's see if it works. I'm predicting it will work, but it will be slow, or we'll get TLE. Okay, yeah, probably TLE. Yeah, okay. So this is too slow. So there probably is some way that we can just jump also maybe another way we can do it is to use O of n space. But the idea is you're trying to use constant space. So maybe I could first, before I attempt to solve it with constant space, I could solve it with linear space, which in that case we could just do the, so this solves it in constant space, but quadratic time. I could solve it in linear space and linear time, but I think the real kind of trick with this problem is that constant space. So this is O of n squared time O of 1 space. So if we try, I'm going to do O of n time O of n space, and then maybe from there I can condense it into O of n time O of 1 space. So, and like the problem says, there's lots of different, there's 3 ways to do it, so at least. Okay. So what I was thinking before is if we just store every number, so we know that the starting number, so if we have like 1, 2, 3, 4, 5, 6, 7, and k equals 2, we know that what will be at position 0 is 6. So the length minus k. So start position of new array equals length of nums minus k. Like so that, so the array at that index. Similarly, so we would say that, so maybe we could have like a pointer at I, which will be like what we're writing to, and then j, which will be where we are currently. So then we would say, so we're going to write to I what j is, and then we could move both of them up like that. And now we're going to write to I what j is. And then we move them both up. So now j will wrap around here. And then we're going to write to I what j is. So 1, right? And then we would just keep doing that. 2, 5. Sorry, I don't think that's 5. This should be 3. And then 4, and then 5. So the trick with this is we need to know, we still need this end space. But I think that's definitely beats the solution. So let's try coding that. We're at 15 minutes. Okay, so let's try coding that. So I'm going to have two variables, two pointers. So we'll say that I equals 0 and j equals length of nums minus k. Yeah, so if k were to be... Alright, so let's just think about this case before I get into edge cases. So we're going to have something like this. Alright, and then what's our stop condition? We want to loop until I goes to the last index. So we could just say while I is less than length of nums. And then we may need to mod here to ensure that, well, I will never need to mod, but j wraps around. So we'll say that it equals j plus 1, and then we'll mod that by the length of nums. So that way it wraps around. So if we get to like here, the length is, now this is 8, so it'll say 8 mod. Actually, it would be 7 mod 7, which would go back to 0. Okay, so then we're going to write to, so we'll say nums of I equals wherever j is. So we could store a copy. So like clone is nums.copy. And then we'll say clone of j. So in the original, wherever j was in the original is what we should make nums of I. And I think that would do it. So unless I'm missing anything, we could try this one. Okay. So this one should be faster, but it's going to take up more space. So in this case, it's failing with k. So this is an edge case. So I set it to the length of nums minus k. So the problem is that k is 0. So we're going to get 1 minus 0, and then it's trying to index at position 1 when it's only length of 1. So index 1 does not exist. So in this case, is it because k equals 0? So let's ask that question. So if we have an array of size 3 and k equals 0, then it will initialize j to 3 minus 0, which obviously is bad. So I think maybe we should, we could maybe mod this by length of nums, and that would handle that one edge case where if it's a 0, or if k is 0, then it will just wrap around. I don't know if that makes sense. It makes sense in my head because it will turn it into 0. And so basically what that does is whenever k is 0, j will, okay. So whenever k is 0, I and j will be at the same spot now. And then it'll just write to itself, which works algorithmically. It may be a better implementation to add an if statement. Just say like if k equals 0, then... Okay, so even the memory is pretty good with this one, huh? It may be better implementation to just say like if k is 0, just return nums, and then don't do any of this. So just assume that if you're at this part in the code, that you have that k cannot be 0 because we've already would have returned nums. Okay, so that's really weird. I think VS Code or LeetCode is a little consistent because my last submission I got 90% memory and this one I got 10. Yeah, it's really inconsistent. Did I mute myself? No. Okay. So I'll just keep it like this for now. Okay. So this part requires you to clone. How much time are we at? 20 minutes. So I could maybe try one more thing. This part requires you to clone the array. So is there a way that we could do it without cloning? With the two-pointer solution, what if we like changed where I and J were? Does that make a difference? Because in this case, I is behind J. But I think it would always be. Like for instance, if J was the one that started at 0, we would write to so I is where we're writing to. So so J would have to be 2 steps behind I. So we could have it be like this. Or could we somehow know like so this would read 1. So where 1 is here in the final product. So we could, if we put 1 here, so we had, yeah, so this would still mess things up because when J gets to here, it would read 1, but we need to know that it's 3. Maybe it's not possible to do constant time and constant space. It could be, but either way, yeah, I think I'm gonna leave it here. I'm pretty happy with this solution. Yeah, I'm pretty happy with the solution. There probably is a way to do it in constant time and linear space, but I'll just leave it like this for now. And I think I'm going to record another video since I'm sort of like a day behind right now. So, yep. All right. Well, thank you guys for watching. Today was day 75. So I'll see you guys for day 76.